Sorry. Yeah, so the idea of today's lesson is to kind of put a lot more flesh on what we've been looking at, not just to say why it's increasing, but how much the temperature will increase, when it will increase, where it will increase, and the same for some of the consequences of temperature increasing. Rainfall, precipitation will increase, the sea level will rise. So those are the major areas that we'll be looking at, and there are certainly more areas that we could look at, but there's only so much that one can do in one lesson. So before we start to do that, we're going to have a look at this rather complicated looking graph. And I've said the goal of this lesson is that we're going to look at, you know, what's going to change, how much is going to change, but the climate scientists don't tell us that. They're not prophets. They don't sort of stick their finger in the air. They don't know how much things are going to change. What they do instead is to present us with a set of scenarios. And when I say scientists, I mean particularly the Intergovernmental Panel on Climate Change, which is a UN organization. It's about 1,300 scientists who are collaborating. And the last major report they produced was in 2013. And in that report, they presented 4 main scenarios. And they called those scenarios representative concentration pathways. And what they mean by that is the concentration of carbon dioxide in the atmosphere. So they're not saying how much, they're not basing the scenarios on the level of emissions. They're basing the scenarios on the level of concentration of carbon dioxide that we end up with at particular points in time. And you may remember from the previous lesson that we talked about how a particular level of carbon dioxide in the atmosphere will give rise to a certain heating effect, and that is called radiative forcing. So if you look at the kind of outer edge of the Earth's atmosphere and you say there is, for example, 2 watts per square meter of energy that the Earth is absorbing, more than it is emitting, then that is a radiative forcing of 2. And so these 4 scenarios are based on the particular levels of radiative forcing. So RCP 2.6 means that it's got a radiative forcing of 2.6 watts per square meter. All right, so are you all with me so far? Or is that, just do shout if you're not, if it's not clear. But if you don't shout, I'm going to assume you're okay. All right, so we've got these 4 scenarios that they're talking about, and we don't know which scenario will actually occur. And what the scenario that occurs will depend to a large degree on what humankind does. Once carbon dioxide is put into the atmosphere, it only disappears from the atmosphere very slowly. They say that about half of what humankind puts into the atmosphere now will almost certainly still be there 1,000 years from now. So it does go down slowly. It is absorbed slowly, but only slowly. So if you look at the lowest of those scenarios, in that scenario, the kind of, it's almost like you're sort of turning the tap off almost entirely or very rapidly. And you can see that in that lowest scenario, the green one, the level of carbon dioxide in the atmosphere does gradually decline. But in all the other scenarios, we're continuing to put carbon dioxide into the atmosphere, and the amount of carbon dioxide in the atmosphere continues to increase. In this purple one, in number 4.5, it kind of reaches a peak around about the end of this century, I think, or maybe a bit earlier. In the top one, it doesn't reach a peak even by the end of this century. We continue to put more and more carbon dioxide into the atmosphere. Okay, and then I've put a kind of little crosshairs onto the diagram, which shows where we're at the moment. So we're in April 2021, and we have just passed 420 parts per million of carbon dioxide. So we're actually above the highest scenario at the present time. Yeah. So even though we've had a year of lockdown and much reduced air travel, there has still been a steady increase in the amount of carbon dioxide. So yeah, so that's not incredibly encouraging. So worldwide, with lockdown, CO2 emissions in 2020 were about just under 1% greater than they were in 2019.
Do we know what the main cause of? I mean, is it animals? Is it power stations?
I can't tell you the answer to that, John. I don't know where that mostly is coming from. I'm assuming it's mostly human rather than animals, but I couldn't tell you for sure.
Okay, thanks.
Okay, so it's just really important that we grasp that probably the main sort of scientific study or piece of work is this work that's been done by the IPCC, that they have these 4 scenarios that they're looking at. We don't know which one will happen, but the longer that we wait before we take action, the harder it will be to reduce the amount of carbon dioxide that's up there in the atmosphere, because there will already be so much up there. And kind of temperature rise is determined by how much carbon dioxide and other greenhouse gases there are in the atmosphere. Okay, so that's going to be dictate, or be a basis for a lot of the discussion that we're going to go on to. So what I'm going to be doing as we go through this study, I've got these 3 areas: temperature, you can see on this thing on the right, temperature, precipitation, sea level. Each case I'm going to try and pick out what the scientists expect to happen this century, have a brief look at what they might tentatively think might happen next century, and then look at what has been happening in the recent past, meaning perhaps the past century, and whether that gives us a basis to think, yeah, their forecast is probably reasonable. So the first one is just temperature. I don't think we need to spend a lot of time on this. You've got the 4 scenarios you can see in the sort of left-hand section, 2046 to 2065. You've got the highest scenario takes us up to 2-degree rise in temperature from around about the beginning of this century, and reaching close to 4 degrees by the end of this century. When it says like 2081 to 2100, that would be the average for the last 2 decades of this century. Yeah, so we've got those four scenarios. I don't think there's any need to say anything more than that. However, it's important to understand something about the what they refer to as the spatial distribution of temperatures, or it varies according to where you are in the world. So what do you notice about these charts? You've got the lowest case scenario on the left, the worst case scenario on the right. What do you notice from the map?
Obviously, it's going to get very hot in most of the world.
Yes, all right. Well, if we end up with this RCP 8.5, the worst case, yeah, definitely. Where do you notice
it's going to get hotter in the North and South poles?
Yes, exactly. Hotter in the North and South poles, in the Arctic and Antarctic, and hottest of all in the Arctic. And that's because in the Antarctic, the ice sheet sort of basically remains in place and keeps it from rising too much. Whereas in the Arctic, it's likely to be disappearing more. Okay. But compare land mass and ocean, which gets hotter.
It gets hotter on the land.
Yeah, exactly. So the continents, the land gets hotter. So I'm going to give you an incredibly simple little quiz here. This is that's the right-hand map, RCP 8.5. I've kind of blown it up a bit. So concretely, what temperature rise might people in the Azores and people in central United States expect by the end of the century, or by the last 2 decades of the century?
So that's 2 to 3 degrees in the Azores and 5 to 7 degrees in the US.
Yeah, absolutely. All right. So although we've got a
good read.
Yeah, although we've got a temperature rise overall of perhaps 3.7 degrees, we said down here, for the worst case scenario in the US, the actual increase they're forecasting for central US is more like 5 to 7 degrees, a whole lot hotter than the worldwide average. Okay. All right, so let's just continue. If you look at this map, incredibly simple question. Where are the hottest areas of the world?
Towards the equator.
Towards the equator, yeah. The Sahara, the Saudi Peninsula, and
Australia.
Australia. Great. Okay, so that's a pretty simple question. And then another really simple question. Do many people presently live in the hottest areas?
Yeah.
Who said yes? Who said no?
I said
no.
yes.
All right. Yeah, Sherry, go on. Do you want to explain that?
Well, isn't that like the 1040 window somewhere there? And loads of people live in, in those areas. Millions of people.
Yeah, well, I think there's a lot of truth in that.
India's in there.
In
Iran's in
India,
there.
yes. I mean, I think the 1040 window is wider than that. And if we think about what we know about, for example, the Sahara, the Saudi Peninsula,
Turkey.
well, there's Turkey is
Iran.
slightly outside that. Yeah, okay. I mean, by and large, yes, there are lots of people who live there, but it's not the most hospitable place for people to live generally. People live in Kuwait and Dubai and Bahrain and places because there's masses of air conditioning and so on. But there's certainly not much scope for agriculture in a lot of these areas. A lot of them are very dry already.
Aren't they mainly desert?
Sorry?
Well, you've got a bit of orange and red in India. And like Bombay's around there.
Yeah, okay. Yeah, all right. I think where I'm going with this is that we've got areas that are kind of naturally less suitable for human habitation, and these hot areas are generally, people do live in them. We do business in them, but they're mostly less suitable for habitation. So as we see temperatures rising, it's pretty likely that those areas that are not very suitable are just going to increase. There'll be wider areas that are not fundamentally suitable or ideal for human habitation. And this is a headline that came in BBC News. Climate change, more than 3 billion people could live in extreme heat by 2070. And this headline was a result of a paper being published in the Proceedings of the US National Academy of Science titled The Future of the Human Climate Niche. And they were projecting that, depending on scenarios, 1 to 3 billion people could be left outside the climate conditions that have served humanity well over the past 6,000 years. So that's the main thing that I want to say about temperature, what we can expect, when we can expect it, where it's going to be, these temperature increases. So that gives them just a basic picture. But then if we go on to next century, but won't bother reading that. This is, you can see here, obviously there are 4 rows, 3 columns. So in the top column, you've got, no, start again, in the top row, you've got RCP 2.6, the least worst scenario, and you've got the pictures for middle of this century, end of this century, and then end of next century. And then the second row down, you've got RCP 4.5, same thing, 3 periods of time, until you get to the bottom row, which shows the very worst scenario and what that might look like by the end of next century. So just wonder if anyone has any comments on any of those.
So somebody needs to,
Right.
sorry, I was going to say somebody needs to invent a machine that gets the carbon dioxide out of the air.
Yep. Yeah, well, we've had rather a lot of machines putting it into the air for quite a while, so it's going to be tricky. Yeah, but.
So, Simon, the worst case scenario, the bottom right hand side, I mean, that shows the actual sea warming up as well, doesn't it?
It does, yeah.
Are there any evidence or opinions out there about at what point the planet becomes uninhabitable or inviable for human life?
Well, I haven't seen that, although I must admit I haven't particularly gone looking. I know that you've got quite a lot of these sort of eminent scientists who support this thing called the doomsday clock, where they are seriously concerned about the actual existence of life on Earth. And they've been making some very strong and strident comments about the direction we're heading in. And I think these figures for the end of next century, they're kind of hidden away. You don't quickly find them. Mostly people are talking about, the whole emphasis is on trying to keep to within maybe a couple of degrees temperature rise this century. But it's just really important to understand that once that CO2 is up there in the atmosphere, it just remains there and continues to heat the planet. And that will go on in the following century and get into an increasingly worse situation.
There's one thing acknowledging that it's going to become more uncomfortable, more dangerous, and less land available. But I think the things that are going to motivate the powers that be, or even ourselves, is survivability and reversibility.
Yeah. Well, there's not very much scope for reversibility.
To map out.
Yeah.
As a human being and a non-scientist, as an ordinary person, can you hear me?
Yes, we can hear you, Tandy.
Yeah, I'm just saying to myself, if God would intervene and make things normal, but God is sovereign. He keeps the rules, the laws that he has made. He keeps them. He keeps to his own territory. And also us as human beings, they failed to keep our own territory. So he will just let the natural thing happen and just let it happen, and that's the end. Then he will intervene and just end everything. I'm just thinking as a human being, as a non-scientist.
Yeah.
That's all.
Yeah, I think, that I agree with you, Tandy, that God allows man to experience the consequences of actions that he takes or humankind takes. And, if someone sets out to murder someone, they end up murdering them, and then they will have to, be judged afterwards. But God doesn't prevent people from experiencing the consequences of human actions, and this is the direction of travel at the moment. We have
From
to say
our
that,
point of view, we got to try and, it would be nice to try and figure out, or I don't, that's probably not the right approach, but is this a Sodom moment, or is this a Nineveh moment? Is there an opportunity to turn given the warning?
right? Okay, that's a very big question.
Yeah.
I mean, I guess my answer is that we try as hard as we possibly can to turn things around. Yeah, and I think, raising awareness is a huge part of it. When you realize the kind of future that we're having prospect, there's a possibility of doing something if people understand the gravity of the situation. I must admit, when I looked at this, first of all, I thought of a couple of verses in Revelation. I'm not going to put them or talk about them now, but I've got them in my notes. But basically, certainly a couple of places in Revelation, it does talk about, various woes coming on the earth, one of which is great heat and burning up of trees and scorching of people and so on. So whether that's related to this or not, I don't know. Anyway, we're going to continue. Not terribly happy thoughts at the moment. I've got those, but I'm not going to read them. So we're now going on. We've had a look at what is forecast for this century, what is forecast for next century, and now we're just going to have a quick look at what's been happening in the recent past. So this is actual temperature changes from 1850 to 2012. Anything you notice from this graph?
Going up.
Yeah. All right. So it does support that picture of, from the start of kind of industrialization and start of, humankind burning a lot more coal and oil. We've seen this temperature rise, which is what we'd expect and is what is happening. Right? Anything else needs to be said on that? Okay, then I'm going to continue.
I'd have thought from the Second World War and all that area that it would be sharper going up, but perhaps the population was a lot lower than it is now.
Yeah, I mean, we do see that it seems to start to rise quite rapidly from about 1970, doesn't it?
Yeah, it does.
Yeah. Yeah, and there was someone in the class, in the group we had yesterday, someone was asking, well, doesn't it seem to kind of go down a bit from, I don't know, 1870 through till 1900? And it does look like it does, but I have no explanation as to why that is. So I don't have explanations for the fine detail, but the big picture is it is going up as we would expect. Yeah. Okay, and then one more graph. This is the observed change in surface temperature from 1901 to 2012. What do you observe in that?
What are those big white spots?
I think those are areas where they didn't have data.
Oh.
And why there is a cooling south of Greenland, I don't know. Someone asked that yesterday, but I'll preempt that question.
I was just looking at that. It looks to me like, there's the Gulf Stream swirl that comes up to the UK and then swirls off to the left. That might be the cold water being sucked down from the Arctic.
Could be, you don't know. Yeah.
And also the desert of the world, that there will be there will be increased more in the desert.
Warmer in the deserts, you're saying, Tandy?
Yeah, I think that's the Sahara and that's the Gobi.
Yes.
And the Mojave, South America.
Yeah.
But also some areas where it's not desert, like in Canada, they seem to be higher.
Yeah. I think there is something in what you're saying. I think the thing that I kind of picked out from it was really that it's the large continents, the large land masses, which have got warmer, whereas the oceans haven't got warmer so much. So the actual what has happened does support what the scientists are saying will happen. You know, that the land masses will get warmer on average, and they're saying that on average the land will get about 50% warmer than how much the planet as a whole warms.
It's interesting here, the previous ones you showed us, the Russian continent was not in the red zone. They were the least hot, but this chart shows you that they are the most heated, most increased.
Okay, I mean, I think Russia is getting pretty hot here.
That wasn't the chart I was thinking of. There was an earlier one that showed maybe it's the current position.
Oh, okay. Yeah, this
That
one maybe.
Yeah.
Right.
So North America, Canada and Russia, Northern Europe is not super hot. But yet the chart you've just shown us on the degree of increase over whatever period it was shows that Russia and Canada have increased the most.
Yeah.
More purple.
Yeah. Okay. Yeah. I mean,
but that's made them more habitable rather than more uncomfortable.
Yes. Yeah. Okay. I totally agree. So you're absolutely right. So it's not simply that the hotter are getting hot, the hottest are getting hotter. It's the large areas of land mass that are getting hotter. If they're cool to begin with, then it might become more pleasant for some people. But another issue up here in Russia and Canada is that at the moment, these are frozen wastes. They're covered in tundra, sort of frozen ice and bog and stuff like that. And as that tundra thaws, then that creates different problems. Okay, we're going to go on to the subject of rainfall, or use a more technical word, precipitation. And I'm going to show you a video. And yesterday I managed to make a mistake in the way I shared it and no one could understand what they were saying. And I hopefully will do it correctly this time. So just wait a minute. All right, so this is a bit of a BBC program called Weather World, which I had only hardly ever watched before this, if ever, but I kind of was just caught it on beginning of this week. I thought it's just really relevant to what we're looking at. And just to forewarn you, listen carefully because I'm going to ask you a couple of questions afterwards, all right? And we'll watch it for about 2 minutes. And if you can't hear it, just raise your hand or something, so I'll know that you can't, and hopefully I'll be able to fix it.
Weather World is now in its 7th year, and this is our 18th programme, and I can count on just one hand how often we've been filming, and it's dry, let alone sunny, so this really is a collector's item. What isn't so rare is how often we say on this programme, a warmer world doesn't necessarily mean a drier one. January, and the UK endures another round of winter flooding. This time parts of Greater Manchester and Cheshire are hardest hit as Storm Christoph sweeps through.
My living room floor literally looks like a waterbed because the water's gone straight under it. I've had to turn off all the electricity, all the gas, everything.
It was another wetter than average winter in the UK, and as the climate warms, our atmosphere is being loaded to produce higher rainfall amounts. Scientists say for every 1 degree Celsius of warming, the air can hold 7% more moisture.
The fact that we're increasing moisture also means that moisture is moving more effectively from the regions where it's evaporating to the regions where it's coming down as rain or snow. So this movement of moisture is actually making the water cycle not only more intense, but also more variable. In the drier regions, the atmosphere is almost becoming more thirsty because it can hold more water. It's more greedy for that water, and it's sucking it up more effectively and moving that into storm systems, into monsoons, into the high latitudes where it can fall as heavy rain. So in some senses, the warming of climate because of increasing greenhouse gases is causing very dry events to become more dry, as well as making very wet events to become more wet.
Last October, the UK had its wettest day ever recorded. The UK Met Office says such a deluge, without human-induced climate change, should happen once every 300 years. But by the end of this century, under a medium greenhouse gas emissions scenario, it could happen every 30 years.
Later this year, leaders from...
All right, so I've got just 2 or 3 questions. How much more water can air hold if it gets 1 degree warmer?
7%.
Well done, Sherry. Well, listen. All right, I'm just going to share content again. Okay, so here we are. Those are my 3 questions. So, I mean, if we think about it, you know, we all know that on a warm day, clothes dry quickly. So I'm sure it's no surprise to us that as the temperature gets warmer, the ability of air to hold water increases quickly. And there's a little graph that just shows you that. You know, as soon as you start to get above sort of 15 to 20 degrees, there's a rapid increase in the air's ability to hold water, and therefore water evaporates more rapidly. So you get more take-up of water from the seas, from the land, and much more of a drying effect as temperature increases. Right, so that was the first question. The second question, according to the professor, Richard Allen, what effect does global warming have on rainfall?
Increasing.
It increases, that's the general effect. Yep, absolutely. A couple of other things that you mentioned, or at least one other thing.
Well, dry areas will
areas
be more dry.
That was certainly one of them. Dry areas become drier, wet areas become wetter. Yep. And there was one other thing that he mentioned. I don't know if you noticed it. He said that it becomes more variable.
Yes, and there become more storms and hurricanes or something.
Yeah, that's also totally true. I'm not sure if he said that, but certainly the scientists saying that there would be more extreme weather events. Yeah. Okay. So the third question is, if rainfall patterns are more variable, and to some extent there's more rain generally, but there's also more variability, who will that affect, and what effect will that have?
I think those living near rivers are more likely to get flooded, I think.
Absolutely. Yeah.
Global change, climate change. The globe becomes more. The weather becomes unpredictable.
Yes. And who will that affect if it becomes more unpredictable?
Farmers.
Yeah. So, you know, even if they have exactly the same amount of rain as they had the previous year, but it comes at different times, that's going to cause difficulties for them because they won't know when to sow, when to reap, and so on. Yeah, so life becomes more difficult. All right, so that's a big picture. And now we're going to go back to the IPCC report and see what their projections are as to what's going to happen to rainfall. So can you just have a look and say which parts of the world are going to have more rainfall and which parts are going to have less?
So around the equator.
Absolutely, that gets more.
The polar caps.
Absolutely, yeah.
We live in a region that doesn't get anything. We never get anything.
No. I mean, there has been rain sometimes in Dubai. I remember a great flood one time in Dubai.
We haven't had any rain this year. They seeded the towns.
Right. Okay. And which areas get drier?
Tropics.
Yes, exactly. I think what you'd call subtropics, to distinguish between the tropics around the equator and the subtropics, you know, to the north and the south of the equator. So the subtropics get drier. Is it mainly the ocean areas or the land areas that are getting drier?
The land as well as the ocean.
Yes, that's right. Yeah, but you can see large kind of swathes of the Pacific and the Atlantic seem to be getting less rain. But obviously you've got Southern Africa getting less, and also in that whole area around Brazil, if you look at RCP 8.5, that's getting significantly less water or precipitation.
That's a rainforest.
Aha, yes, and that is significant. Yeah, so the rainforest itself is in danger because of deforestation, but it's going to be in greater danger because of climate change. So the two things acting together create great danger for the existence of the rainforest. And there are people who are suggesting that even through deforestation alone, the existence of the rainforest is in danger, the future is in danger, because it relies on being big enough to be self-sustaining. And so that if the rainforest does start to decline, then it will gradually turn into a savanna. The trees will die off. As the trees die and decay, they will then release a lot more carbon dioxide, huge amounts of carbon dioxide into the atmosphere, which is generally not what we want. All right,
I'm
so
trying to think around what's the impact of the oceans getting less rainfall.
I'm not
I
sure.
can only think of that just means they're going to be more susceptible to evaporation and therefore more rain in the system.
Yeah, I wasn't particularly trying to draw any sort of great conclusions of the oceans either getting more or less. I think when I looked at this, I thought to myself, well, you know, a lot of the places it just doesn't seem so bad. You know, you look at Europe and Africa and so on. There may be sort of modest change, but overall, you know, you look at Africa under RCP 6, and it all looks kind of mostly sort of shade of light green. I know there are some yellowy bits there, but you kind of think to yourself, it's not bad at all. But then I started thinking a bit further about things, and what I sort of woke up to is that one of the great dangers that we have to be concerned about is drought. And drought isn't only influenced by the amount of rainfall, but it's influenced by the amount of evaporation. So if you're getting more evaporation and it's not made up for by the amount of rainfall, then there will be a net drying effect. And that is what the scientists expect. And I will go on here. So I'm just going to read it. We don't need to worry about the abbreviations, but AR4 climate model projections and CMIP5 ensembles both suggest widespread drying and drought across most of southwestern North America and many other subtropical regions by the mid to late 21st century. So although there is greater rainfall overall, and that will cause flooding in lots of places, it is also going to cause drying and drought in many places, which may sound weird. But it goes back to this sort of principle that the scientists keep on going on about. Dry areas get drier and wet areas get wetter. All right, so far? Okay, I'm going to press on because we've still got a little way to go. So this is what the scientists are telling us in this great big, it's 1,500 page long IPCC technical report. And they say that 1 degree of temperature rise will result in 7% more evaporation. But at the same time, they're saying that this 1 degree of temperature rise will result in 1 to 3% more precipitation. And I just could not get my head around that. I can't figure out how it is that water is going to evaporate, go up into the atmosphere, and not then come down as rain. And I gave up trying. I contacted the person who gave last week's or the previous talk twice. He's got a doctorate in cloud or something or other, science, to try and get him to explain it to me, and he couldn't. But anyway, if what they're saying is correct, then it kind of explains why we get a drought situation, because we're getting more evaporation than we're getting precipitation, and so there's a drying effect. And so you can see this drying effect on this chart. So again, you've got the 4 scenarios. Anyone want to make any comments on what you notice here?
Well, it's pretty bad in the Americas and Europe.
Europe is looking very dry.
Yeah.
Yeah. So I think this is a really helpful set of maps and graphics, because, like I was saying, the sort of precipitation on its own doesn't really tell you what to expect, because it's the evaporation and precipitation together that I think are really critical. And this tells you that the drying effect, and yeah, it certainly looks like it's going to make life very difficult for agriculture in a lot of places. All right. Can I continue?
Yeah.
All right, then I'm going to go on. Sorry, it was rather loaded with information, this one. Right, so we've dealt with this century. Now we're going to have a very brief look at what the scientists expect for next century. This may look an absolutely baffling set of charts, but what it is that you've got 4 different groups have done projections for what they expect to happen. So these are all the worst case scenario, the 8.5 scenario, but they're done by 4 different groups of scientists. And so they're very similar. So you get on the top row, the middle of this century, and then the middle one in the top row, the end of this century, and the right-hand one, the end of the 22nd century. And I think the picture is just really more of the same, the situation becoming steadily more extreme. Okay, so that's what is projected for 170 years or so from now. Anyone want to make any comment on that?
It's like showing a lot of rainfall in the North and South poles.
Yeah, yeah.
So we won't have any ice.
Yeah, it means precipitation. It could be falling as snow. Okay, I'm going to continue. So I'm not going to talk about that one. I meant to delete it. We're now talking about what's been happening in the last 100 years or so. This is from the American Environmental Protection Agency. They had a slightly different graph, but similar, but I just downloaded the data and put it into a new graph. You can see that precipitation worldwide is highly variable year on year, but there's an evident upward trend. So it supports what the scientists say. Okay. You may wonder how they get that information. I don't want to spend a lot of time on it. Over land, there are rain gauges. There are also some rain gauges in the oceans, but not very many. I discovered as I was researching it that rain gauges on oceans, some of them, they listen to the sound of the rain. They listen to the pitter-patter of the tiny raindrops, and they figure out how much rain is falling from that. But mostly, the rain, they don't have rain gauges in the oceans, but they found out, or figured out, that around the oceans, the salinity of the sea is not the same everywhere. In the tropics, there's much more evaporation than there is rainfall, and that makes the salinity of the sea in the tropics, what makes it more saline. But on the other hand, in the northern or around the poles, there's much more rainfall and very little evaporation, and that makes the seawater less saline. But they can use this changes in salinity to figure out how much rainfall there has been. And that means that there's a method by which they can say not only how much rain has fallen over land, but also how much rain has fallen over the sea. And these measurements that they come up with help them to confirm the picture of the increasing rainfall. But I don't want to go on to that too much. We've got one more section to do. And then after that, oh, actually, no, there's one more bit here. So another piece of evidence is desertification. There's desertification happening in many parts of the world, is what the scientists predict. They would say, they can't say for sure that any particular area of desertification is due to climate change because of the variability of climate change. On a global level, yes, we're expecting a drying effect. On a localized level, there might not be a drying effect, but overall we're seeing a massive amount of desertification, and currently 46 out of 57 African nations are experiencing desertification. So it's further evidence of the effect of climate change. I just picked this up. This is a headline from some news article. It said, world's largest desert has grown even larger due to climate change. And that's what they're claiming. I think the IPCC would probably say, well, yeah, in general, yes, we'd expect desertification to happen, but it's hard to sort of say in any specific region that it is due to climate change. But we won't dwell on that. Many places are saying it's not only the temperature, but it's, increasing wind plays a big part in desertification because it blows away topsoil. So that's Chinese scientists are making that comment. Here it is a picture in Namibia. So there's multiple factors going on there. But what the IPCC does say pretty confidently is that over the next, say, 4 decades, we're going to see a lot more people than at present living in arid and semi-arid regions. Okay. So I'm going to press on, and we're going to come to the last bit, which is sea level change. So here's what the IPCC expects to happen as far as sea level is concerned. You've got the least worst scenario and the worst scenario that they're looking at. What do you observe from this graph, these maps?
South America sea levels are dwindling in South America.
Yep.
And near the Greenland area, the sea levels are getting dwindling, and in the Arctic as well.
Yeah. There's some isolated places where it actually, the sea level goes down.
Yeah.
Yeah, remarkably. Yeah, and yesterday, some people asked me, well, why is it not the same all over the world? And I wasn't really able to answer that. At least I can tell you very quickly why that is to some extent. So it's saying that you've got changes in wind patterns and also changes in ocean currents will affect sea level rises in localized areas. So that because the currents, I guess, were causing higher sea level somewhere, if that current reduces, the sea level will fall to some extent. They're also saying that when the distribution of land ice changes, that affects the shape of the Earth. It also affects the gravitational fields of the Earth, and that affects sea level. And there are also some localized variations because of changes in tectonic plates and sediment compaction and various other things. So there's 3 or 4 things that would affect sea level change on a local basis. But you can see, well, let's go on to the next one. This is showing the least worst scenario and the worst scenario in that big figure on the left. So you can see the kind of the red line that runs through it, showing the kind of the mean, and then the pinky band shows the kind of range of probability. So in the kind of worst case scenario, what sort of sea level rise would be expected by the end of the century?
One meter?
Yeah, in its worst case, that would be 0.98 meters is actually what they say in their tables. Yeah, more likely about, 0.7, 0.75, what they would expect. But even in the least worst case scenario, you've got 0.4 meters of sea level rise. So if we had that level of sea level rise, do you think it would affect a lot of people?
Yes.
Yeah.
Yeah. Yeah, it certainly would. Huge number of people around the world who live in kind of islands which aren't very much above sea level and coastal areas.
We don't be employing Dutch engineers.
Yeah, that's right. In the Netherlands, large parts of the Netherlands are already below sea level. Okay, so that's what is in forecast. There are presently, I think, 1.5 billion people around the world who live less than 5 meters above sea level. So I think there's a large number of people this could potentially affect, and it's already affecting them. So we go on to next century, what's expected. Under the least worst scenario, the sea level change is expected to still be less than 1 meter, but under the worst scenario, it's going up to between 1 and 3 meters. So that's now going to seriously affect, probably 1 billion people, something like that, who will find that their places of where they live are seriously threatened. But then the scientists are also saying that even if we limit the temperature rise to about 2.5 degrees, that in itself is going to be sufficient to melt the entire Greenland ice cap over the period of about 1,000 years. And that would result in a sea level rise of about 7 meters. Okay. All right, and then we've got just 1 or 2 more things. If we go on to the recent past, of the last, there's been sea level rise has been reported probably for 100 years, but if we look particularly at the last 17 years, these are the things that have contributed to sea level rise in millimeters per year. So the biggest contribution from glaciers and thermal expansion of the water. So that is the end of this kind of flying of what, when, where, how much kind of questions in relation to temperature, precipitation, and sea level. So I've just got one thing to finish, but then after that, we've got Jonathan is going to tell us about an area that he is interested in. So let's just finish with that picture and ask, does anyone want to make any final reflection on what we've been looking at there?
Can I comment? I think there are there's an awareness of this, not least from Greta Thunberg, in fact, and I think we are making efforts to try and pull the temperatures down. As I say, it's not all doom and gloom by any means.
Yeah, yeah. No, certainly there are lots and lots of people around the world who are extremely alarmed and advocating, and there's a lot of activism. The reality is, though, that we have not reached a peak in terms of the level of carbon emissions, that they are continuing to go up year by year. We need to reach that peak and to see it start to fall. So yeah, I agree with you, Jonathan. There's reason to hope, but the trajectory is still not good.
Do you have any information on the natural cycle of temperature increase and reduction over millennia? For some people, some of the anti-mob point to the fact, well, this just might be part of Earth's natural cycle.
Yeah, there's a lot that's written on that, and I could probably either send you some stuff or point you in the direction of stuff. There's, I can't remember, Andrew, were you with us last lesson?
Yeah, I can't remember whether I could hear you all the time, but yeah.
Oh, okay, all right. I mean, the previous lesson, we had a discussion about why we can say that this is not simply one of these natural cycles, but it is clearly something that is quite, it is absolutely out of the usual, and particularly when you see the increase in carbon dioxide levels, you can go back so at least 800,000 years, if not more, and you look at ice cores from Greenland and the Antarctic, and they can give you lots of information about temperatures, about CO2 levels, and so on. And then when you look at that, you find that what is happening at the moment is absolutely out of character with anything that's ever been observed in those sort of 800,000 years.
Okay.
Yeah.
Is there some way to remove the carbon dioxide from the atmosphere?
That's a really interesting question. The reports talk about different technologies, and people are looking at technologies. So in the kind of grand plan of this course, we've had 8 lessons which are on scripture. We've got this lesson and last lesson, which were, if you like, on science. Then we've got 2 lessons which are talking about the situation. So we're going to just try and we're going to have one which will be looking more at Africa, next one, and then the one after that will be looking at the Mekong Delta. But then the last 4 lessons are going to be on strategy. And I think within those 4 lessons, we will take a look at possible sort of scientific technical solutions that are being talked about. You know, there might be political solutions, there might be technical solutions, but that will be the time to consider, are there technical solutions to get CO2 out of the atmosphere? And people are certainly looking at them without question, but how feasible they are, that's really another question. But yeah, I mean, I think if you could do it with using some amount of energy, well, you know, let's build lots of nuclear power stations, let's get lots of energy and pull the stuff out if it's possible. Forestation, so you've had deforestation is putting CO2 into the atmosphere. If you plant masses of trees absorb carbon dioxide out of the atmosphere, so they sequester carbon. So they're great things to do. But for every person to absorb the amount of carbon that we in our typical lifestyle are producing, we probably would need to have about 200 or so trees around us.
Okay.
Yeah. So it's a tricky one. So, but yeah. Any other questions or thoughts or reflections?
I suppose for having a machine to take the CO2 out of the atmosphere is you'd also have to work out the carbon and all the issues about how much it to make it and how much to run it, etc., and whether or not it will be effective.
Yeah, but it may well be that if you've got lots of, I don't know, wind energy or nuclear energy, you may have enough energy to be able to pull carbon out of the atmosphere. Just thinking out loud, perhaps it would work. I don't know, but we'll try and take a look at that in the later lessons. Okay, well, let's we've reached 12 noon, but we're going to give Jonathan sort of some time to talk about a subject that he's interested in related to not doing damage to the environment. So Jonathan, over to you.
Right, are we live? Right, friends. Can you all hear? Yes, good.
Yep.
I served as an engineer in the Merchant Navy from 62 to 75, 10 years at sea on a variety of ships. The majority were diesel-driven ships, and in fact, from the 1970s, with the doubling of fuel prices, steam turbine ships were phased out from usage. In the case of the diesel ships, we use diesel fuel, which is a clean fuel going in and out of port, or residual fuel when away at sea. Now, these fuels, residual fuel particularly, produces nitrous oxides and sulfur oxides, which are great pollutants. The International Maritime Organization is instructing all ships to reduce their discharges. The sulfur is generally being removed by the oil refineries, so it's not in the fuel. In the case of the nitrous oxide, improved consumption of the fuel, but now progressively, although fairly expensively, all ships have been fitted with scrubbers, so 97% of the NOx discharge is being removed. So they are taking considerable steps to reduce the fuel. At oil refineries, fuel is delivered as crude oil out of the ground, and that is warmed up and various constituents are taken away from it. So you've got LPG, gasoline, diesel oil, jet fuel, kerosene, etc. And the cleaner the fuel, the less pollutants. There is a move now to go to other type fuels. As I speak, there's a brand new cruise liner being launched last year, 2,000 passengers, 750 crew. She will endeavour to eliminate those NOx and SOx exhausts. She'll run on LNG or other much cleaner fuels. She also has rotating sails, which will generate electricity. She also has solar panels for generating electricity. So quite a lot of steps being done there over the next many years. And it's not a question of the rich countries doing it and the poor not, because the poor companies who don't get their ships up to standard, they won't be allowed to trade into the rich countries anyhow. So I think there are efforts there to go for better fuels. And indeed, they are looking at burning hydrogen. In fact, now that doesn't generate carbon discharges, so that is on the cards as well. And I think that applies on land as well, the possibility of cars and trains operating on hydrogen as well. Slightly concerned it is highly flammable, but I think you can do it in such a way. Well, a further improvement, most ports now, certainly Southampton, when large cruise liners are docked in the port, they turn their engines off and plug into shore power. So again, a reduction of pollution in the port. The other environmental concern is in ballast water. Common for the ships to load their fuel into what is known as double-bottom tanks below the cargo holds. And as the fuel is consumed from each of the tanks, they're filled up with seawater. Also on the large tankers, when they're running empty between ports, they will fill the cargo holds with seawater. But seawater picked up in the States, discharged in Europe, or loaded in Europe and discharged in Australia, is taking contaminants across the world and causing harm. So now generally all the ships are being fitted with purifiers, so it treats the water as it's loaded on, it kills off all the microbes as well. So the answer is yes, quite a lot of steps being taken, in fact, in the marine industry to cut down. But clearly, the number of ships is not getting smaller. The latest large container ship, which was stuck in the Suez Canal for 6 days, was 60 times larger than one of the ships I served on from the cargo point of view. So an awful lot of ships going around, and I do question what they're actually moving. In fact, it seems to be we're importing shoes and handkerchiefs from China and then exporting other soft goods back there as well. So I'm not convinced we simply need the level of trade we've got. Same in some ways, I feel that's how we're flying as well in that. I mean, if we were rationed to a holiday when we can go on holiday for every 2 years rather than 1 year, would that be a hardship? Do we have to go abroad every single year? So I think it is on beholders. So there are being steps taken to significantly reduce the pollution. Will we win the race or not is a debatable point. But I think in spite of all that Simon has highlighted of what may happen, I think we recognise that, and certainly, I again say to Greta Thunberg, have you seen her statue outside Winchester University yet? I was actually getting young people right across the world, so standing up and saying, sorry, I, Mr. So-and-so, age 20, in fact, no longer want my country to be polluted, in fact. So I think there is a voting pressure group there now to say to the politicians, and indeed, Greta Thunberg, I don't want you to say we'll look into it. I want you to say what you're going to do about it, in fact. And I don't mean in 20 years' time. I mean now, in fact. Let's get on with it. Right on that, in fact, my next door neighbour has a couple of plug-in electric cars, and speaking to them recently, he was saying the cost of charging the car is about a quarter of the cost of refueling it with petrol, in fact. So there are steps to get us to a much better place. Any questions?
I thought that was excellent, Jonathan. And I think the thing that struck me and I liked about what you're describing is that you described a lot of kind of incremental processes. And I think that when we are addressing steps to tackle degradation of the environment and climate change and so on, that, you know, we've got to be able to propose to people incremental steps that they think, yeah, I can do that and I can do this. And also when you were talking about making changes to lifestyle, I mean, that's what Priscilla and I have chosen to do. You know, we would now, for example, choose to go on holiday overseas once in 3 years or once in 4 years, something like that, as a way to reduce the amount of flying that we do. But we wouldn't advocate to people to try and make just extraordinarily big steps that they can't achieve, but to encourage them to take steps that they can swallow.
That's after that. I remember holidays as a child in the 1950s. As I say, yes, it usually rained, but if you're on the beach in a swimming costume, it didn't really matter. My grandmother and her sisters were well coated up in the coast with their thermos flask, and they were happy enough as well. So you don't need to go to the sun. You can have perfectly good holidays in this country, rain or sun.
Yeah. I must admit, I do like to have some rather warmer seawater than we get in this country.
It's not too bad in Bournemouth in the summer, in the middle of summer. Might have 2 days when you can get into the water.
Yeah. Okay. Anyone else want to sort of react to that, with Jonathan's presentation there?
I think it's very encouraging to hear that the shipping industry is taking some pretty concrete steps.
Yeah.
You know, it's really great.
Yeah, it's interesting. Okay, well, let's close there. I'm going to say a short prayer and then we will finish off. So, Lord Jesus, we've had just kind of a massive download of information. There's a huge amount here to absorb. And I just go back to kind of what I prayed at the beginning, and that there's this verse, I think Paul was saying, praying for one of the churches, that their love would increase in knowledge. And we do need to have knowledge in order to function as you would wish us to show care for people, to show care for this world. And we pray, Lord, that as we digest these things that we've been looking at, and we think about what is the rational, the logical and spiritual approach and response that we need to make, that it won't just go in one ear and out of the other, but we will think, because of these things, we need to take steps, we need to respond. We may need to change our own lifestyles. We may need to speak to people, to advocate, to be activists. But guide us, help us, Lord, please, to gain head knowledge, but then that will then be reflected in how we speak and how we act. So we pray these things in your name, Lord. Amen.
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 Can I just ask, I don't think we've got anyone present to do what Jonathan did today and John did 3 weeks ago, to talk about what they are doing or what they would like to do. Anyone want to volunteer?
Hello, Marilyn.
Oh, hi, Marilyn. All right, well, you mull it over. I might send an email to you at some point and see if I can twist your arms. Okay, well, I shall say goodbye for the moment.
Okay.
Bye.
Thanks.
Bye.
Thanks very much, Simon. That was a great session. Thank you.
Okay.
Thank you.
Bye.
Bye. Bye.
Bye.